Bootloaders and customizing the boot process. In this nugget, we're going to examine the boot process. First, we'll talk more about bootloaders, specifically Lilo and Grub, and then we'll talk about customizing the startup process and how to control which scripts and services are started when you boot up your system. So pull up a chair and let's get to work. Let's start this nugget by talking about bootloaders, and let's talk about some generalities before we talk about the specifics of any one particular bootloader like Lilo or Grub. So there's two ways to set up your system. One way is that you make it so that the BIOS loads the IPL from the master boot record. All right, so let me decode some acronyms here. IPL stands for the initial program loader, and sometimes you'll see that referred to as the first stage bootloader. All right. The MBR is the master boot record. You should already know about that, I think. The master boot record is a particular area on your hard drive that the BIOS knows about. It doesn't need any help to find the master boot record. So what option 1 here is saying is that the BIOS loads this first stage bootloader from a particular area of your hard drive. Now the other option is more of like an indirect option. So in this option, the BIOS loads a separate bootloader, which in turn loads the first stage bootloader from a partition on your hard drive. Typically that partition is /boot, but it could be any number of partitions depending on how you set things up. But it's got to be the partition that holds the bootable image. All right, so in this option, it's indirect. You're loading another bootloader, which loads the first stage bootloader from a partition on your hard drive. All right, so that's the two basic ways to set things up. Now let's talk about some specifics, and we're going to start with Lilo, which is the Linux loader. Now here, I've just typed out part of a lilo.conf configuration file. It's not complete. It's just, the most common things that you'll see in a lilo.conf configuration file. The first two lines here represent that the Lilo system will prompt the user for input. All right, and it gives the user 50 time units. I believe those time units are milliseconds. So it gives you 50 milliseconds to respond to the prompt. If you don't type anything in that 50 milliseconds, then it takes the default action. And here the default action is Linux. Now, Linux isn't, it's just a label, and you can see that the same thing is down here under this image tag. The label here is Linux. So the default action is to boot this image with these options. All right. Now, this could say anything. This could say, Perry's favorite kernel or something. All right. And then down here in the label, this should say Perry's favorite kernel as well. So whatever this default is, there should be a label corresponding to it somewhere later in the configuration file. And like we talked about in the last nugget, you can have multiple images in your configuration file, and those images could correspond to things like different kernel versions or just different kinds of kernels. So they might both be 2.4.7 kernels, but one has certain modules compiled into it or certain modules left out of it for streamlining purposes or whatever for you to test out. Okay, so even though the kernel versions might be the same, the labels have to be different, and the labels are what lilo.conf uses for like the default action here, for instance. All right, then the boot directive specifies the boot device. If you said here /dev/HDA, that puts the bootloader into the master boot record. All right, but if you specify a particular partition of a device like HDA4, for instance, then that's not putting it in the the master boot record. Okay, so that's how you take action to do the two instances that we talked about on the previous slide. All right, this is where the second stage bootloader resides. So in the /boot directory, there's a file in there called boot.b. That's what this is saying. So that's where the second stage bootloader is residing. And then we get down to the image. All right, so the image is /boot VM Linus 2.4.7-10 in this instance. That's telling us where the kernel image lies that I'm going to boot from. All right. Now, and like I said, you can have multiple images here. All of these directives apply just to this image. If there's another image that you want to specify, then you have to specify all new directives for these for that particular image. All right, we already talked about the label. The initial RAM disk contains things that are not in the kernel that are necessary to boot up. So certain modules or things like that would be put into the initial RAM disk, and you can make it you can create the initial RAM disk with the make init rd command, and you can look that up to find out more about that. But basically, what you would do there is you would say make init rd, and then you would specify, slash boot slash init rd. That's a T there, init rd dash 2.4.7.10, whatever you've called it here, and then give the kernel version number like 2.4.7-10. So this would be all on one line. Make init rd space boot init rd 2.4.7-10 followed by a space 2.4.7-10, and that would create this image that we're talking about in the initrd directive here. All right, so like I said, this is a sample lilo.conf configuration file. Anytime you make a change to this configuration file, whether you're changing which image you want to boot by default, or changing the timeout, or doing something more serious like changing the location of the second stage bootloader, after you make any change to this file, you have to rerun the lilo command, which lives in the /sbin directory. So you have to rerun this in order to make the changes to this configuration file effective. If you don't rerun that, then you're going to get errors when you try to boot up in your system. Now, Lilo has a particular way of distinguishing the errors, and that is with these letter commands or letter designations as Lilo is booting up. So if you just see an L and then things stop, that means that the first stage was loaded and started. So if the first stage was loaded and started, but that's it, like that's all that happened, then what happens is that the second stage bootloader can't be found. Okay, it wasn't even, the second stage bootloader wasn't even loaded into the system. And so what will happen is then, in addition to just an L being printed out during the boot process, there would also be a 2-digit error code. And the 2-digit error code would be in hexadecimal format. It would look something like this, like 0x followed by a 2-digit combination, but because it's hexadecimal format, the digits are from 0 through 9 and from A through F as the possible codes. So it might look like something like 0x0c as the error code. Now what you should do is you should look up Lilo hexadecimal error codes or something like that to see the exhaustive list. And there will also be remedies for how to fix things. Sometimes the remedy is as simple as, just try again, because obviously this didn't apply to you. Maybe it says your disk is write protected or something, and your hard drive isn't write protected. Just something happened during the boot process that messed things up. All right, so if an LI is printed out, that means that the second stage bootloader was loaded, but it wasn't started. Now, in that particular case, there might be something like the second stage bootloader was moved. In the previous slide, we talked about the directive. It said something like install equals /boot /boot.b or something. Now, if you moved this second stage bootloader from this file boot.b to somewhere else, and you didn't change this install directive, then you would get this error code. All right, or if you did change this in the lilo.conf configuration file, but you forgot to run /sbin/lilo to update that configuration file, again, you would get this error code. Now, if we get down to LIL, that means that the second stage bootloader is started, but it can't find a descriptor table. Then LIL question mark says that the second stage was loaded, but there was an incorrect address. Okay, typically there's some sort of disk problem with that. Okay, and then LIL dash says that there's a corrupt descriptor table, and finally, if LILO prints out, that says victory is ours. Okay, the whole thing went through and it all booted. Now, I haven't gone into exactly, what the problems are with each of these error messages and how to fix them. But again, you can delve into that, look up in the Lilo man page, also look on the internet for fixing things like, if you have a corrupted descriptor table, what exactly do you do? I don't want to go into all that detail for this particular slide. Well, another bootloader that's out there is Grub, and Grub is it's a more modern bootloader, and it's probably more heavily used now than Lilo. It works with more kinds of file systems. It's more flexible, and you'll see it's the default on a lot of different versions of Linux now, from SUSE Linux, which is what we're using on this machine, to Red Hat, and so on. Okay, now on SUSE Linux, there's the grub configuration file, like we said in the last nugget, is in the boot grub directory, and the file is called menu.lst. Okay, now that file is not meant to be edited by hand on SUSE Linux. You're supposed to go through the YAST program, right, the system tool. So if you want to alter the grub configuration, you should go to the main menu and then go to the YAST tool and bring YAST up in order to edit this. Now, one of the advanced options within YAST is to hand edit this file, but you should only do that if you can't make your changes via the menus and things like that. Okay. Now, in other versions of Linux, this file is not called menu.lst. It's called grub.conf. It might live in the boot grub directory. It might live in the /etc directory. Sometimes in the etc directory, there's a grub.conf that is like a symbolic link to a file in the boot grub directory. And so, depending on your version of Linux, it could live any number of places. If we take a look at the menu.list file, you'll see a little bit more about what grub does and the configuration of grub. All right, well, before we move on to talk about Grub, I just wanted to talk about Lilo just a little bit more. I searched for Lilo user guide in Linux, and it brought up the user guide, and section 5.2 is bootloader messages. Okay, so there's different kinds of bootloader messages. There's progress and error messages while it's loading, and messages indicating disk access errors, and also error messages in response to invalid command line input. Okay, we've already talked about the progress and error messages, the L, the LI, the LIL, the LIL question mark, and so on. And they are also detailed in this document. But there's also these disk error codes. And here is the hexadecimal codes, and you can see 0x00 is the first one, 0x01 is the next one, and so on, and they just work down through the list here. So if you get one of these codes, there's no magic to decoding them. You just have to look up in the user guide to see exactly what the code means. In here, they also talk about what to do to get around things. Something like try omitting the compact option, or try booting again because this shouldn't happen. Things like that. So it will guide you a little bit further on how to resolve that particular error code. Well, like I said before, depending on your version of Linux, the grub configuration files can be named slightly differently. They can be in slightly different locations, that sort of thing. So if you're going to alter the grub bootloader, you should pull up some sort of documentation specific to your version of Linux. And I've done that here for my machine. Here's a SUSE Linux administration guide about grub. All right, so this document's nice. It starts by talking about what grub is, how stage 1 and stage 2 booting works, talks about all the different file systems that are supported from grub, and then it goes on to talk about the 3 main configuration files that grub uses. Now, the first one we've already mentioned, that's boot grub menu.lst, and this is the file that contains all the information about the partitions and the operating systems that can be booted with grub. So if you've set up a system that will boot multiple versions of Linux, or it boots some Linux and Windows, okay, or it boots all SUSE Linux but just different adaptations of the kernel. All those different entries are contained in menu.lst, even if they refer to some other operating system. Okay, and now inside of there, just like in the Lilo configuration file, there are different images, and there's also a default. So when you start up your computer, you get this grub splash screen, and it gives you the choices of all the things in menu.lst, and you can choose from any of them in order to boot up. If you don't make a choice, you have some particular time limit, and if you don't make a choice in that time limit, then the default action is taken, just like in Lilo. Okay, there's also a device map, and this translates between Grub device names and Linux device names. This is somewhat of a sticking point for people when they look at a Grub configuration file. They don't understand what the device names refer to, so we'll look at that more carefully in a couple seconds. And then there's the grub.conf configuration file. Now, like I said, on some versions of Linux, grub.conf actually is a symbolic link to a grub.conf in the boot directory, like where menu.lst is on SUSE systems. But in SUSE Linux, grub.conf is actually its own separate entity, and it contains parameters that you need to install the bootloader correctly. All right, so this is its own separate entity, and also, like I said, if you want to alter the menu.lst or alter grub, you should be doing that from yast. Okay. Another nice thing about grub is that all the boot parameters can be changed prior to booting. So there's a whole section in here, editing menu entries during the boot procedure. Okay, this you can click on that and go into detail about how to edit the menu entries. Basically, what you're doing is during that splash screen, you can highlight a particular choice, but instead of hitting enter to boot into that particular operating system or that particular image, you can hit the letter E for edit, and then you're allowed to edit the elements from menu.lst, so you can change the booting process. Okay, you can boot from a different partition. Maybe you've made an error to menu.lst and something isn't working, then the editing feature allows you to correct that on the fly. So you can go ahead and boot into a particular image or operating system, and you can change the entries to menu.lst right from the command line, right from that splash screen. Okay. There's also a section in here on configuring the bootloader with YAST. Like I said, this is how they want you to change the grub configuration files in SUSE Linux. They want you to use the graphical tools. And there is the fallback in the graphical tool of being able to hand edit the menu.lst file as well as the other files. Okay. All right, and like I was also saying, that there is the naming conventions are sometimes confuse people. So let's take a quick look at that. In the grub configuration files, you'll see device names as like HD0, 0. Well, typically we think of device names when we think about the dev directory as things like dev/HDA1. HDA1 refers to the first IDE hard drive. That's what the A refers to. And then the 1 refers to the first partition on that drive. If we were talking about SCSI drives, then that would be an S that would start there, right? SDA1 would be the first SCSI drive and the first partition on that drive. Okay, so for grub configuration files, though, HD00 refers to the exact same thing as HDA1. So the drive numbers, instead of using letters like they do in the dev directory, we're going to use numbers, and we're going to start at 0. And partitions, instead of the first partition starting at 1, we're going to number the first partition 0. Okay, so HD00 refers to the first IDE hard drive and the first partition on that drive. Okay, just like down here, HD0, 1 is the second primary partition on that first hard drive. All right, so that element of numbering confuses people. You shouldn't really let it confuse you. Once you know how it works, then you can translate this sort of notation back into the notation that we're used to very easily. All right, well, now what I want to do is talk about how to customize the boot process in Linux. And before we get into any specifics, let's take a step back and make sure that we understand how the boot process works in Linux. Well, the very first thing that happens is a program gets called /sbin/init. That is the mother of all processes. Every other process in the system that gets started is either directly or indirectly started through sbin init. All right, so that's a very important process, and there's a file in the etc directory called init-tab that is the configuration file for the sbin init script. Okay, now sbin init is controlled by this, and this has all sorts of details in it, the init-tab file. One of the things that gets controlled is the default run level that we move into. Remember, Linux has different run levels, and those run levels correspond to different levels of functionality existing in your Linux system. So here you can see the default run level is 5. That's the most common run level that we're in Linux. Run level 5 has networking, it has X Windows, has multi-user capabilities, so many people can be logged in the session at once. And as you move down from number 5 down to number 0, you get less and less functionality. So for instance, well, run level 4 is actually unused, but run level 3 does not have the X Windows interface, but it does have networking. Run level 2 has no X Windows and no networking. Run level 1 is just single user mode, something you would use if you were doing backups or some kind of disk repair or something like that. Run level 0 is just used for halting the system, and run level 6 is used for rebooting the system. So those run levels are you're in those sort of temporarily while you're halting the system or rebooting the system. So, but like we said, run level 5 is the default one that gets used, and that is set in the init tab file. Now, all sorts of other things get set in init tab that we don't have to talk about. Things like, what happens when there's a power failure, what scripts get run on reboot, or all sorts of things that are very detailed that we don't have to go into right now. I just wanted to make sure that you understand that there's the sbin init process, and that's controlled by this init tab file. Now, the other thing that happens, the first thing that the sbin init process does is it runs a script in the init.d directory called boot. And if we look at this script, this is the very first script to be executed from init on system startup. Okay, this runs. We should never touch this file. We should never mess with things. If we want to execute certain things on our system during the startup process, there is another file called boot.local, and this file is the one that we should mess with. So you can see this is completely empty, and here it's saying you should add things here that should happen directly after booting, but before we're going into the first run level. Okay, so if there's something very important that you need to do on your system, do not mess with the boot file. That's all set up to do certain things. You mess with the boot.local file instead. Now the next thing that happens is that another script gets called in the init.d directory called rc. Now we're not going to look at this script. It's got a lot of detail in it. Let me just summarize what the rc script does. The RC script is responsible for starting and stopping services. Let's take a look at this directory here, and you can see there's a bunch of subdirectories here, rc0.d, rc1.d, and so on. Now these subdirectories there are scripts in those subdirectories, and the scripts that are called by the RC script depends upon which run level you're entering or exiting. Okay, so when I start up my system into run level 5, then there are scripts in the rc5.d directory that are executed. When I'm shutting down from run level 5, there are scripts in the rc5.d directory that are executed. Okay, since our default run level is run level 5, let's go into the rc5.d directory and just take a look around and see what's in there. If we look in there, you'll see there's a bunch of scripts in here, and the scripts either start with a K or they start with an S. K stands for kill and S stands for start. So when we're booting into run level 5, when we're starting up into run level 5, all of the scripts that start with S are started. And the order in which these scripts are run depends upon the 2-digit number immediately after the S. So like S01 scripts are executed before S05, and that's executed before the S06 scripts, and so on. Okay, so this is what's controlling what is started up on your system by default when you go into a particular run level. Now, let's look at a couple details here, okay? One of the first things that gets started when we enter into run level 5 is this S05, the network script. So basically what this is doing is it's starting up networking on my system. This script is not executed like in run level 1, for instance, when we're in single user mode. We're not doing any networking. If we looked in the rc1.d subdirectory, there would be no instance of starting up networking there by default, because we don't want that in run level 1. Okay, but in run level 5 we do run it, and we start it up early in the startup process. Then let's look at some other stuff like SSH, okay, a secure shell, or CUPS, the printer service. All right. These things rely on networking, and so the networking system must be started up before we try to start up SSH or CUPS. Okay, same for NFS. All of these things rely on networking being started already. So the order of the scripts in here is critical. Similarly, when we shut down from run level 5, if we look at the kill parts of this, the kill scripts in this directory, you'll see that CUPS is shut down and SSH is shut down before networking is shut down. Okay, so those kill numbers are lower than the kill number for networking, and so those things get killed before the networking service gets killed. And this makes sense. It should be kind of like what we call in computer science a stack process. So the first things that happen in the startup process should be the last things that happen in the killing process, because what's happening there is, you know, all those things rely on networking, and so we need to start networking before we start them, and we should shut those down before we shut down networking, because when we shut down networking, it would cause those to get killed, but it would be killed in sort of an ungraceful manner. So you want to do things in sort of the opposite order that you started them. You want to kill them in the opposite order that you started them. All right, well, it's time to wrap up our nugget talking about the boot process in Linux. We started this nugget by talking about the bootloaders Lilo and Grub. Lilo and Grub have a lot of similarities. What a bootloader does, remember, is that it starts up your system, and it allows you choices of what image you're going to boot into. Whether you have choices amongst different versions of Linux, different kernel modifications that you've made, you know, which one you want to boot into, or whether it's between two different operating systems like Linux and Windows. Lilo and Grub can both be configured to allow you choices in what you can boot into. They both have quite a bit of flexibility. We talked about the error codes for Lilo, so you can determine when things don't boot up correctly, at what stage they went wrong, to help you narrow down the possible troubles that are being caused. We also talked quite a bit about Grub. I pointed you to some resources. Remember that the Grub configuration files vary from one version of Linux to another, what their names are and where they might be located. So make sure you look at resources for your particular distribution before you delve into messing with Grub. Then we talked briefly just about run levels. Remember, the run levels correspond to how much functionality you're going to give your system when you boot up. So once you've made the decision about which kernel version or which operating system you're going to boot into, if you're booting into Linux, then you also have the choice of which run level to boot into. And the run levels, by default, you will boot into run level 5, but there are other run levels that might be useful to you, like run level 1 for single user mode, or run level 2 so you can test things without networking, and so on. But remember, run level 5 is kind of like the fully functioning Linux run level that will allow you to have X Windows, networking, and everything else that we expect from a Linux system. And during the boot process, remember, there's a bunch of scripts under the etc init.d directory that controls which services are started up when you boot up your system. And for run level 5, they were contained in a subdirectory of etc init.d called rc5.d. And we looked at the basics of how that directory was laid out. We talked about the processes that are started and the processes that are killed. In the etc init.d directory is a file called skeleton that you can use as sort of a baseline if you want to add scripts to, like, the rc5.d directory. If you want to start up some extra service that's not contained in there now, then you should look in the skeleton file in etc init.d as a, you know, sort of a template for how you should set up the scripts to add something to your system. But remember, if you're going to add a startup script or a kill script or both to a particular directory in your system, you need to make sure that you give it a number so that the ordering makes sense. You don't want to start up a script that relies on networking before the networking service has started itself. Well, I hope you found this nugget informative, and thanks for watching.